Okay, fourth hour advanced algebra. This is Mr. Gentz. Today we're going to divide rational expressions. Okay, and let's start by reviewing what it is to divide fractions. So you guys can go ahead and fill out these notes as we do it, and then you're going to get your assignment. Okay. Um, so let's first think about this. Dividing by 2 is the same as multiplying by what? So if I have, say, 6 divided by 2, that's the same as 6 times, and the answer is 1/2. Multiplying by 1/2 is the same as dividing by 2. And a lot of you can think about that and understand that. Multiplying by 2 is the same as dividing by 1/2. So let's say you want to take 6 times 2. That gives you 12. Well, that's the same as 6 divided by 1/2. So what do we learn? We learn that when dividing fractions, just multiply by the reciprocal. When dividing fractions, multiply by the reciprocal. You don't change the first fraction, change the second one. So we're going to rewrite this as 4/7 times 21/2. And as you look at this, you recognize that 21/7 becomes 3/1, and 4/2 becomes 2/1, and we get 6. Okay, the next problem, same type of situation. We take 3/5 and we multiply it by 15/4. 15/5 is 3/1 times 3/4. That does not simplify, so we get 9/4. That's our answer. Nothing changes if we have a negative. I always put the negative with the top. -1/9 times 45/4. And you can see that 45/9 reduces to 5/1. Times -1/4 is -5/4. And our last one, 10/9 times -27/200. Well, -27/9 reduces to -3/1. And 10/200 reduces to 1/20. So we get -3/20. That's our final answer. So we're going to use that same type of operation in order to divide rational expressions. Rational expressions. And if you don't see it expressed as a fraction, like number 1, then just put it over 1. Okay? So 32p squared, q to the 5th, over 1. Or multiply by 7r over 4p cubed, q squared. We're looking for anything that cancels here. Looks like the 7r and the 1, those don't reduce at all. Okay, so I just have that 7r over 1. But 32/4 reduces to 8/1. P squared over p cubed, that's a p in the denominator. And q to the 5th over q squared, that reduces to q to the 3rd in the top. So you can see I have 56r, oh, I'm sorry, I wrote p to the 3rd. Let me back up here, sorry about that. That's 8/1, and then we had q to the 3rd, not p to the 3rd. We had a p to the 2nd in the denominator. I'm sorry, just a p to the 1st in the denominator. Okay, there we go. So we have 56 q cubed r over p. That's our final answer. Try our next one. 6x to the 4th, y to the 5th, over 5r cubed times 10r to the 6th over 8x cubed y to the 7th. Try to simplify some pieces here. The 6 over the 8, that reduces to 3 over 4. The 10 over the 5, that reduces to 2 over 1. X to the 4th over x to the 3rd leaves you with an x in the numerator. Y to the 5th over y to the 7th, that's going to be a y squared in the denominator. R to the 6th, R to the 3rd will be a r to the 3rd in the numerator. And we get 6x r cubed over y squared. 4y squared, excuse me. And you can see that the 6 over the 4 reduces as well. So 3x r cubed over 2y squared. That's my result. Number 3, we have to start by factoring. So I have 3x plus 2 over 2x minus 1. I'm going to multiply that by 4 minus 8x over 9x plus 6. So I multiply by the reciprocal. As I do that, 3x plus 2, that's already factored, and 2x minus 1 is already factored. But I'm going to choose to take a negative 4 out of the top. And if I do that, I'm left with 2x and a minus 1. And I'm going to take a 3 out of the denominator. And I'm left with 3x plus 2. If you do that, you can see that the 2x minus 1's cancel. The 3x plus 2's cancel. I'm left with negative 4/3. Number 4, that's a little bit more challenging. We have to factor 2x squared plus 7x minus 15. Sometimes to save time, folks, what I do is when I see this division sign here, is I write multiply by the reciprocal. So 2x squared plus x minus 1 over x squared plus 6x plus 5. So sometimes I just get rid of that altogether, and I write multiply like that. Saves me a little bit of space. You can choose how you want to operate with that, but that's how I choose. Got to factor this first part. 2x and an x. And negative 15 factors a negative 15. I'm going to go with negative 5 and positive 3. And I'm going to try, or positive 5 and negative 3. I'm going to try a plus 5 and a minus 3. And remember that we check the inside and the outside. The inside is a negative 3x. The outside is a positive 10x, which makes our plus 7x right there. Yeah. Now I'll factor our next part. I have a 2x and an x. Looks like I'm going to go plus 1 and a minus 1. That'll work for me. Oh boy, 4x squared. This looks challenging. I'm going to try a 2x and a 2x. Might work, it might not. I'm going to go a minus 3 and a minus 1. So I'm going to check the inside and the outside to try to get that negative 8x. But negative 2x and a negative 6x. Yep, that works out. And the last one is an x plus 5 times an x plus 1. So lots of pieces here. Let's see what we can get to cancel. X plus 5's gone. 2x minus 3's gone. 2x minus 1's gone. X plus 1's gone. And we are left with 1. That's beautiful. You might say, well, how do you know you're left with 1? Well, you have the same thing on the top as you do on the bottom. So let's say you have 5 over 5, that's 1. So we have the same thing in the numerator as you do in the denominator. We've learned that that's 1. Okay? Finish this off here real quick. All right, next one. Again, so I like to save a little bit of time by going x squared y squared over x squared plus 2xy plus y squared. So I rewrote it as multiplication. I'm going to factor the top. The top is the difference of two squares. The next part, I have x squared, y squared in the top, and in the bottom, what multiplies to x squared? We've got x times x. What multiplies to y squared? We have y times y. And let's see if we get the middle. X times y is xy. X times y is xy, and that makes my 2xy. So that is factored correctly. Let's see if we can find something to cancel. The x plus the y's go away. X squared, y squared over xy, this will go away. And these will be reduced to just the first power. And so you have xy times x minus y over x plus y. And that's as simplified as that expression gets, unfortunately. No simpler in that situation. Let's try one more. Multiply by the reciprocal when you see division. So x is 6 minus 9x to the fourth. Divide by x cubed minus 3x squared. Let's cancel that off. This factors to x minus 3 times x minus 3. And what can we factor out of the top? Well, we'll do the bottom first. I'm sorry, we'll do the bottom first. You can take out a 4 out of the denominator, or if you want to be tricky, take out a negative 4. We're left with an x minus 3. You can see that's going to be very helpful to us. Times, numerator here, x to the fourth, you're left with x squared minus 9. And what do you take out of the bottom? An x squared, and you'll be left with an x minus 3. Look for things to cancel. X minus 3's go away. X minus 3's go away. X to the fourth over x squared, that will reduce this to 2. And so we have x squared times x squared minus 9 all over negative 4. And that's our result. Now, some of you maybe recognize that the x squared minus 9 does factor into x plus 3 times x minus 3, but nothing ends up canceling, so it's not really all that important that we express it that way. But if you did express your answers x squared times x plus 3 times x minus 3 all over negative 4, that's fine as well. They're equivalent. If they ask for the answer in factored form, they'll be different, but they don't. So let me post your assignment for you. I don't know, do something. At least have a meeting. Okay, here we go, folks. There's a worksheet, and there's a bunch of problems on there. For the division ones, I want you to focus on numbers 29 through 33, and then 36 through 50. Do it on a separate sheet of paper. And the answer should be on the back side so you can check your work. If your work simply has the answers written down, then you receive 0 credit. Make sure you're showing your work the entire way. You're going to have the rest of the time to work. Good luck. I hope you do real well. We'll take questions tomorrow when I get back. Thanks. Have a great day. Bye.